Hi everyone, this is the first chapter of our diving into ethics. In this section of the lecture, we're gonna go through the water element. We'll study the basics of water physics as well as practice water animation through two exercises: a droplet falling and creating a small splash, and bigger splash from a waterfall. This should give you the base to understand water and its density, but also liquids' motion in general to be able to apply viscosity to it later in the course. Before jumping directly in the topic of the class, I'd like to make a fourth word about it and present a bit what water is when coming to FX animation. First, you have to know that water is maybe one of the hardest elements to animate due to its high level of dispersion characteristic. The water element, when coming to its simplest form, not ice or snow, is a really flowy and ethereal effect. Energy and physics are keys if you want to play around with water and other liquids in general. When animating water, you need to convey everything coming to shapes, flow, size, variety of movement, synchronization, and desynchronization when breaking down in particles. Each water animation, whether it's a splash, a wave, or even a simple droplet falling, come with its own set of physical laws, energy, and animation specificities. From rough to rendering, you need to think about all these characteristics in order to convey the most believable water-like feeling. Adding to that, the style of the show or project you're working on, whether it's a professional one or a personal one. You just don't have one way to do water, exactly the same as when the sea is forming a wave. It's not the same wave all the time, and you'll keep on learning every time you're trying to animate a splash or a ripple. Even though we all know this, water being a transparent liquid, while translating it on our canvas is basically all about translating light, reflected and refracted light. Why is the sea blue? Mainly because it's reflecting the blue color of the sky. Why does it change color? Because the smallest movement impacts the light refraction on it, as well as the change of color of the surrounding elements. Same as for the other FXs, it's going to be really important to understand how to break down and or associate shapes together in order to make it as accurate as possible. As there are a lot of details in even the most simple drop falling, you need to be able to understand how to summarize these informations to stylize it in a manageable way. For today's class, to begin with, we're going to animate a simple droplet splash. In a second time, we will approach splashes coming from bigger effects like waterfalls. If we decompose the movement of a droplet splash, we can resume it in 4 steps. 1. Free fall. 2. Splash impact. 3. The fall. 4. Droplets impact equal ripples. If we are pushing it a bit, we can add a number 5 constituting in a secondary splash. Let's break it down together to absorb the main theory of it before going to application. First, the droplets free fall. Even though it's a common cliché, a droplet falling doesn't look like that. When falling, the droplet shape will allonge, but it's never gonna have this pointy shape on top. While free falling, because of gravity, the water drop is gonna gain velocity, speed if you prefer. The velocity is what's gonna give it the oblong shape, and the air in contact with the free-falling droplet is gonna make its edges wobble. In a second time, when the water is hitting the surface, because of the energy and speed acquired while falling, it's gonna displace and disturb the surface and create a splash. This splash amplitude and force is gonna depend on the amount of water falling or the mass and weight of the object falling into it. Therefore, the splash of a droplet is gonna be smaller than the splash of a rock. The intensity of the splash is also going to depend on the amount of water the droplet or object is falling into. Let's take rain, for example. The splash from a rain droplet falling on the ground, even slightly wet, is going to be different than if it's falling into a puddle of water. And a rock thrown on a wet ground is also going to generate a different splash than if it's thrown in a lake, for example. Design-wise, for the splash, we need to avoid, or at least try to avoid at all costs, symmetry. That means that while talking about shapes, We're going to look after not having the same height, neither same intensity in the splash like in the example. Of course, you'll be able to play with shapes and asymmetry even more if the splash is oriented, meaning that the element falling inside the water has a certain angle of fall. Also, mind the tension of your shapes. Let's look at some examples I made when it comes to design impact and tension of the shapes. Please note that the shape tension equaling energy is valid for every FXs. As you can see, the upper line is showing a few splashes. These impacts, even though different, have something in common, the tension of their shape. Even though you can't say if it's a big or small splash, the tension in the shape translates the energy of the impact and makes the design more energetic. When looking to the secondary line, you can quickly notice that the shapes are more curvy and they are feeling more soft and less impactful. These kinds of shapes are mostly the ones I can use sometimes for raindrop falling or soft impacts, but I'm never using this shape language when I need to translate something really impactful. Now let's start moving on to stage 3, the fall. As explained before, the fall is being initiated by gravity. Basically, every mass being thrown in the air will eventually go down at one point as its energy is going to shift because of gravity, leading to this object to come back towards the ground or the surface. In that case, the amount of water displaced in the air by the impact of the splash is going to fall down to the surface of our water. We are going to decompose the splash in two parts, the aerial one and the base. The base is going to be the heavy part of the water, the one connected to the surface, containing the compact mass that's going to fall down following a gentle arc way before the aerial part. If you remember the principle number 6, follow through and overlap, while decomposing the base and aerial part, both of them are going to have their own movement. Therefore, the base is going to start moving down, but the aerial part is going to keep on raising up until reaching the top of its curve and then falling back down. The base being heavier than the top of the splash, it's going to fall first, followed by the latter part, and this is true for all FXs too. But we'll talk about it again while studying debris, particles, explosions, and so on. Let's go back to our water. As I mentioned before, water having a really low level of viscosity, the aerial part is going to rip sort off and form filaments that are going to be droplets falling down. But all droplets don't have the same weight and speed, so they are going to fall with delays within each other. The delayed fall is what's going to give us the natural and organic feeling. Though it is not an easy task because it's basically microparticle management, but I will be giving you tips on how I proceed to give each of them their own movement and personality. While falling, these individual droplets are not going to fade in the air. Please do not do that, even though it might seem less time-consuming and easy. The reality is, the droplets are going to fall until the end, even really small. While falling, they are going to follow their own arcs. Remember principle number 8. Every natural element and movement is following an arc, only mechanical stuff like robots are not. And to principle number 8, we're going to mix principle number 9, is in and is out. Because these droplets, as I mentioned, will have their own motion and speed, meaning that while reaching out the top of the curve, they're going to lose speed, ease out, until starting to fall down, ease in, and gain speed again. I compacted the most important things in the image below so that you can have a visual support for what you're going to have to be attentive to while practicing the effect. You will also have all of this recapped in the technical guide made for the water course that you will find in the downloadable. I'd advise you to go through it and keep it open somewhere to take a look while practicing. For the second splash, it's being created by the hole of air formed within the water by the fallen object. I explained it on the screen so that the drawing can support the explanation. While falling and pushing some mass of water in the air to create the first splash, the fallen elements also create a void of air within the water, and while the air gets absorbed by the water coming back to its original shape, it's creating kind of an aspiration movement, making the water close on herself but also clashing it between the two different sides. This clash is going to lead to the secondary splash constituting in a smaller splash than the first one, but obeying the same physical law with a momentum when reaching the top of its curve and a fallback. While animating the effect, you'll also need to watch the volume consistency. It's not because we're not animating a human body that consistency and wobbling volumes are okay. If the volumes of your effect is inconsistent, it will be of poor quality. Though I'm gonna use it to give you a first hand, I personally don't really like to break everything in FX to a bouncing ball, but if it helps you to proceed like that, please go ahead at first. I know that really talented FX artists like Quentin Cordonnier are explaining FXs like that, but to me, even if it can be a good help to grasp the timing and spacing concept of it, I'll encourage you a lot to detach yourself from this ASAP, as it will prevent you from moving ahead and proceed more with understanding the fabric of the FX and its physics. Now, let's move ahead and analyze timing a bit with live reference. As you can see while watching the video below, during the splash timing, there's a burst, then a suspension period before gaining speed and falling again. When dealing with the timing of that momentum, you can exaggerate it a bit depending on the animation style you're looking for, but as we are aiming for a more realistic style in this course, I'll try to follow the natural timing of it as much as possible. Before moving on to live video analysis and demonstration, let's approach the ripple phenomenon briefly. Ripples are created whenever a movement or an action is disturbing a liquid surface, in this case, water. A ripple consists of one or multiple waves forming on a surface that expand and diminish or fade depending on the event happening. If you look at a ripple and try to translate what you see, you'll observe that the light is caught by the upper volume while the shadow will form in its hollow part. Also, in most cases, ripples are being generated in perfect circle shapes. Let's generate a single ripple seen from the top. Let's start by a very rough version of our ripple. Seen from the top, you can observe that when we have the impact, our first base circle is forming. Its timing is going from fast to a deceleration until the surface goes back to an inertia state. When choosing the diameter of the ripples, you need to consider the weight and force with which the object is being thrown or falling. In this case, it's just a random example, so I chose a diameter that is okay for you to be able to see properly how the ripple is working, but later we'll need to think about this parameter. Now let's add light and shadow. Let's see how it moves and behaves. Now that we're done checking the top view, let's think in perspective. The first thing that you need to do when putting your ellipses in perspective is set your perspective grid. Once it's done, let's see how ellipses are behaving when moved in perspective with a ripple-like motion. The front part of the ellipse is going to come toward the camera and the other part is going to move away from it as shown in the example. Now, if we're adding shading to it, it would look like this. Let's approach another ripple case. When you have several objects falling in the water and several ripples, you might think that there would be some interaction between these, but actually all the ripples will continue to travel without interacting with each other. Of course, in the case of a big splash, like a huge rock being thrown or an iceberg breaking, for example, it'd be another discussion, but we'll not move forward to this case for now. To recap, before moving on to demonstration, think about your perspective and how the light and shadows are traveling and accompanying the movement of the ripples. Observing the environment around would be a really good attempt in grasping how water and ripples behave. During the next rainy day, take an umbrella and go observe the behavior of the raindrops and ripple in a puddle of water. It's actually pretty interesting and will give you a great idea of water behavior. Let's animate a droplet. The splash that we are going to start to animate is a profile splash, as it's going to be more handy for you to grasp the first basics of it. Because it's a profile splash, the first thing that I need to do is place my ground line. The ground line is going to represent the surface of the water. So if you're not fixing it, it might happen that the splash is going to wobble a bit, whether in height or placement. In the second time, I'm setting my color palette. As I said before, I'd always advise you to set a color palette before starting any work. It will prevent you to struggle finding your tones that will be set from the beginning. Now that the preparation phase is done, let's start animating the splash. The first step of it is animating the freefall droplet. I set the point of fall of my droplet way above the camera, which is why I don't need to animate it falling from the very beginning. Also, because I set the point of fall of my droplet way above the camera, I can just make a few poses of the droplet falling before just impacting the surface of the water. As said in the theoretical part, the first thing when the droplet is hitting the surface is creating a splash. So right now I'm gonna try to design the splash with creating tension shapes, so straight shapes, and trying also to find a design that doesn't have a symmetry and has an interesting turn of it. To avoid the symmetry, I made one of the edges of the splash higher than the other. Because it's a small splash, we don't have a really powerful impact. When I'm saying this, I mean an impact that contains also like foam and a really huge impact on the water. Starting by a small impact is giving you time to grasp the principle, which is why we are starting like that. As we saw in the theoretical part, the splash is expanding, rising up, and spreading on the sides. As it's a small splash, the heavy part is focusing mainly near and really close from the water surface. The aerial part already split it in the middle, creating a void, blank shape if you prefer. This split between both sides is containing droplets and smaller strands. Now you can see that my shapes are starting to curve because the energy is already getting lost, and we reached the climax of the energy of the animation. While making the water drops falling back, I chose to offset and divide a bit the middle parts of the edges. This is gonna give an interesting and kind of organic twist to my animation. Also, you're gonna hear me say that a lot during the course, but in animation and mostly in VFXs, everything is about taking decisions. The arrows that I'm drawing right now is the illustration of the decision that I'm taking regarding how the splash is gonna fall back and how the droplets are also gonna fall themselves. As their movement is going to be different than the splash itself, the body of the splash itself, they need to have a different decision taken. As we said before, offsetting your animation parts within each other is a really important part of the process. I know it's going to be a bit hard at first, and you're going to synchronize all your elements, but it's going to come with experience. Offsetting is a really tricky thing to grasp, so first, proceed step by steps. Try understanding the global timing within a simple shape and then try to build more and more out of it. As you can see, the two main edges shapes are already starting to fall down, while the one that I choose to offset is still rising a bit. Also, the strands of particles in the middle are still rising, having their own movement. For now, I'm kinda animating straight ahead all the elements together, but you will see later a really nice trick for you to practice and prevent you from animating everything in synchronization. Now you can see I'm highlighting the point where everything is gonna start to be a bit tricky. You will have to handle all the particles plus the strands of water starting to fall off, which is going to be a bit complicated because you have so many elements to track. So how do we track this? This is a tip that I got from one of my supervisors when I was in the studio. Animating all the particles one by one is going to give you this possibility to keep the organic feeling and offsetting of your particle. To do that, you can start thinking about how you want your particles to behave. This could be a really nice point to start off. Kinda as I said before, you're not going on holiday without planning your holidays, booking the hotels and everything. This is a bit the point where we are reaching this idea. Choose the direction and how you want all the strands to fall, trying to give a diversity in the directions that it's going to take. And then, following this decision, you will animate your particles one by one. Particle management is a really tedious part of the job, which is why I'm trying to create a hierarchy in my elements and try from the heavy base and then the particles. Because the heavy base is going to have a first impact on the surface of the water, it's going to be easier to make the bigger element first and then having the small impacts coming after.